So that's the value, and think about the units there. Remember, the units there are really important. This is in liters, atmospheres, moles, Kelvin, right? All right, and then the final thing that the equation asks us for is temperature. Are we given temperature? Yeah, we are. It's in 25 degrees Celsius. So we're given all this stuff so we can start kind of plugging and chugging. But before that, we have to make sure our units match, right? Pressure, since we have atmospheres here, I'd recommend changing this pressure into atmospheres, not the other way around, but you can do it the other way around if you want. This has got to be in moles, so we've got to convert that. And then this has, the temperature has to be in Kelvin, so we've got to convert that. So this is really just kind of one big conversion problem, right? So you got to convert all of these independently before you plug the numbers in there and solve algebraically. So let's get started. Let's just start where right at the beginning, right? Pressure. So we have 745 torr, and we want to convert that to atmosphere. So that's one of the things you want to memorize is torr to atmosphere. So if you remember that correctly, it's 760 torr is equal to 1 atmosphere. So 760 torr down here, so they cancel out. 1 atmosphere, cancels, cancels. Boom, you should get in the end 40 point, oops, wrong number, 0.9803 atmospheres. The 760 is exact, the 745 is not. Cool, that's done. Let's see, next up we're at moles. So N, 655 grams to moles, so 655 grams of CH4, right? What conversion factor do we have there? Well, we have grams to moles or grams per mole, and that's the molar mass. In this case, we're looking for CH4, so you could, find the mass of carbon, 4 hydrogens, that kind of thing. Go ahead, do that. You should get 16.04 grams per mole. So we want to go ahead and plug that in here. The 16.04 grams goes down here, 1 mole up here. That way they cancel. And then what you're left with is 40.835 moles. Probably should have written that lower. Oh well. Next up, we're at temperature. So we've got to go from 25 degrees Celsius to Kelvin. So if you remember that equation, it's that your Kelvin is equal to degrees Celsius plus 273.15 Kelvin, right? So we're at 25. So 25 plus 273.15 is equal to 298.15 Kelvin. Cool. So now what we have to do is plug these numbers in and solve algebraically, right? So I'm not going to show you exactly that. I will show you this, right? PV equals nRT. What we want here is this V. And so think about how you have to reorganize that algebraically. Here it's pretty simple. You're just going to divide both sides by P. So it ends up being V equals nRT over P. And then you want to go ahead and plug all these numbers in there, and you should get an answer of 1,020 liters as your final volume.